Hello. So in this demo, I'm going to showcase like how we can import the raw data in SageMaker Notebook. We can go through the data wrangler techniques, all the EDA and data transformations. Once this is done, we can go again like in the SageMaker itself. We can train the model and deploy on EC2 instance or any kind of instance we want to select. That deployed endpoint, then client can access it from outer side. So I will showcase like this entire flow. So first let's go to the notebook, SageMaker notebooks. I already have one instance running. I'm just opening in a Jupyter lab. So before that, like if you go to here, so in the training jobs, so there is one job is it is saying that like 11 minutes ago one job is completed. Algorithms, so if we have list out any algorithms, then inference. So in inference we can see if there is already created some endpoints or not. Models, if we already created any models, so all these kind of details we can get it here. Once we will run this, we will have endpoints and we can able to see that endpoints over there. Okay, so this is a home page of Jupyter Lab. I'm just going inside this folder. I have lab.ipynb file. And so the basic introductions about this demo is that we have some flight data, flight operating data, and we are going to visualize this data. We are going to training the model, and before that doing all kind of analysis on top of the data to make it like trainable in machine learning model. And we are using AWS a model to train this, and that is a linear model. And I will explain at the time like how we can attach the container of the linear model from external source to like directly into this SageMaker node. So yeah, first step is done. Let me just comment out and we'll move ahead. So understanding the of machine learning objectives. So US flight data, delay data is that, and our target variable is that we have to forecast like how much time or how many minutes that particular flight will be delayed. So forecast the number of minutes a given flight will be delayed. So that is our target. So before that, we are preparing the data. We have data inside this location, so we are getting those data first. And once the data is available, then we will start learning the data. We will start all kind of operations over the data. These are the field inside the data like year, quarter, month, then origin, destinations, all kind of data uh, we have for this particular flight information. Then let me show you how the data looks like. Here dot add. Okay, so year, quarter, month, then a unique carrier number, then flight number, origin, destinations, all this data we have. Also delays about the target variable, that is also here, like departure delay, arrival delay. Okay, now we are just doing some kind of histogram to check the arrival delay. So this is like a data exploration step, nothing else. So we can see that arrival delay in minutes, arrival delay in minutes. Okay, so we are checking like frequency of the arrival delay. And next step is like we are deleting some unused columns like your tail numbers. So somehow it is not very useful, so we are deleting it from the data frame. Now here they mentioned that linear learner, that is the algorithm that we are going to use, and that algorithm requires all the fields should be numerical ones. So we are doing get dummies. So what it will do, that it will convert your categorical variables to numerical variables. So if you see here, previously we have 21 columns only, and now after doing this encoding, we will have more than 400 columns. So right now it is 402 columns. Okay, now we are checking like what is the bucket name. We have one bucket, and we'll do train test fleet and upload this data into again back to the cloud in the S3. So at the time of training, we will directly fetch data from S3 and do a training. We no need to copy the data locally inside this instance. Okay, so basically what we are doing, that df.columns remove this arrival delay. So this is our target column. So that is my x variable, and only this arrival delay, that is my y variable. So basically it is train test split. We are taking a 60% is for training and remaining is for testing. And this train and test.csv we are uploading uh, back to the S3 location. Okay, so next step is like training the model. So in the training the model, now we are training, so data is available in the S3, and we are going to use linear learner algorithm. So in the SageMaker, this algorithms, first we have to fetch that particular image, and that image we are fetching like image URIs dot retrieve. We are passing the linear learner, so that is linear regression algorithm, and we are defining 1, 2, 3 sessions, and we have to pass the region name basically. Okay, so this is like a container, so we are fetching this container image. The next is that we are going to create estimator functions from the SageMaker, where we have to pass this container role. So we have SageMaker execution role, so it will give us role, and we are creating SageMaker session. This is m4.4x large, so this is the instance on which we are going to train. Okay, so this is instance type, output path, all this we are defining in the estimator. The next step is that hyperparameters tuning. So this is a regression problem, so we have many kind of hyperparameters in the regression, so we can define all this using the like model dot set hyperparameters. And next is like we have to define train channel and test channel. So the purpose for train and test is that like train channel we will pass for the feed, and test channel we will pass for the evaluation. So if you see here that my model dot feed, I am passing the train channel and test channel. So test has the 40% data and train has 60% data, and I am defining one job name, flight delay, and like this some kind of time we are passing here. Okay, let me flight delay demo, and today's date is 23/06. Okay, so this is my new job. So it is saying that jobs is started, and it will take near to 12 to 15 minutes to complete the job. It will going through all the epochs and not many stops. It will give all kind of in between matrices whenever it is the training is going on. And this job we can able to see now inside this SageMaker. If we go here, then training jobs. Yep, so here we have flight delay demo 23/06, and this is the time. So this job is right now, it is saying that in progress. So job is going on right now, and once the job is done, we can able to see that that job is done, and the next task is like deploying the train model. Okay, so that job is going on, and we have all the epoch level details. We can see that bed size, epoch number is 15, feature dimensions, auto is bias is true, all this hyperparameters informations we have. And we will have like standard deviation weight, all kind of hyperparameters. We are getting lots of loggings here. And once this all is done, all the epochs are done and model is perfectly trained, the next step we will deploy that model. Okay, so here we can see the number of examples, lot many information is providing by this model. Training, so total wall time is 10 minutes. It took 10 minutes to complete the model training. The next is linear model to deploy, so we can deploy this model, and for that deployment it will took 11 minutes. So I already deployed it in past, so that is the results. And CSV serializer and JSON serializer to serialize the model object. Here we are checking the actual data and test vector. So actually we want to check how our model is performing. So we took one record from test record, and we are saying that model dot predict my test record, and it will give us some output. And we can see that the predicted is -12 and actual is -20, so error is -7.7 minutes. So our model is not that much of perfect. It is giving like the 7.7 minute error. In this case the prediction is paid within the 8 minutes of the actual delay. Yeah, so we can say that it is within 8 minute actual delay. And still we can like enhance the model by setting the more hyperparameters tuning. Yeah, that's all. Thank you for watching this demo.